right? So round robin scheduling algorithm, we are going to use it. Okay. So in round robin scheduling algorithm, each and every task will be executed for given time period. Each and every task will be executed for given time period. That is called round robin scheduling algorithm, right? So we'll see with the code. Okay. So let me open the code. So this is my code. You can able to see here. So I'm going to create same kind of thing what we discussed in your previous program, same kind of thing. Okay. So we are including the header files. Okay, REST51 and then RTX51 tiny. We are including the header file. Then this is to create a task. Okay, like your main function, it will be creating a task. So the job of this task 0 is to create some 4 tasks. The job of this task 0 is to what? Create 4 tasks. That is the job of task 0. So we are creating with the help of system called os_create of 1, os_create of 2, os_create of 3, 4. Okay. Then once after these 4 tasks got created, then I am going to delete it. So I know the system called os_delete. Okay. Then now we will come here. This is task 1. Okay. This is task 1 function. So you can able to see in task 1 what I am going to do is I am going to send some data to port 0. I am going to send some data to port 0. Similarly, in task 2, I am going to send some data to port 1, and in task 3, I am going to send some data to port 2, and in task 4, I am going to send some data to port 3. Okay. So some different data I want to transfer. So for that purpose, I am using some for loop. Okay. For a equal to 255 in the sense that is maximum value. Okay. FF will be what? 255. So that is maximum value. That value is greater than 0, a minus minus. Okay, so 255 to 0. Okay, from maximum to minimum it will be going. And here you can see from maximum to minimum, and here you can see from minimum to maximum, 0 to 255. So some different combination I want to transfer, which means I want to send some data to different ports. Okay, so with some different timing I need to give. Okay, so in round robin technique, so how it will be working in the sense, you can able to see first how it will work, round robin algorithm. Okay, so these are all some 4 ports, port 0, port 1, port 2 and port 3. Okay, so let me run the code. So you can able to see here the port data and all you can able to see here. The port 0, it is getting some data, which is the task 1, which is sending some data. Okay, after some time period, the port 1 is getting some data. After some time period, port 2 is getting data. After some time period, port 3 is getting data. So first, actually some this is my resource. So that resource will be used for a given time period. Okay, that resource will be used for a given time period. That is called your round robin scheduling algorithm. Is it clear? Round robin, that is a fixed time period will be giving for each and every task. Okay, a fixed time period will be allocated for each and every task. Okay, so by default your compiler itself, you will be having one variable called time sharing. You will be having one variable called time sharing. So in time sharing, by default the value is 5 ticks. Okay, 5 timer ticks. You just consider some 5 nanoseconds or milliseconds, like that you just consider. Okay, by default that is 5. Okay, and if you want to change, you can go to this variable. Okay, time sharing variable you can go. Actually that will be available where your program got saved. You don't need to change that one. For your understanding, let me tell you. So in Kale, you will be having this RTX tiny. Can you able to see here? Time sharing, one variable is there, right? Okay, one variable is there. That is a configuration one. That is software defined one. You don't need to change. If you want to vary in the sense, then you can go to this configuration file, configuration underscore tiny, okay, and there you can see this variable. So you can see define round robin timeout in hardware timer text. Okay, so by default in your compiler itself it is defined as what? 5. Okay, so if you give 0, it disables round robin scheduling algorithm. We can use some other scheduling algorithm. Okay, so by default it is 5. You don't go to this file and don't change any value here. Okay, so just keep as it is. Okay, right? So don't go here. For your understanding, I am opening this file. Okay, but you don't open this file. Okay, so so based upon the timer tick, so here your value will be getting changed. Okay, is it clear? Okay, based upon the timer ticks, okay, that is in the time sharing variable, whatever is there, so based upon that your value will be getting changed. Okay, so this is called your scheduling algorithm, task scheduling algorithm. Okay, so here we have some 4 different tasks. So those 4 different tasks will be scheduled for each and every 5 timer ticks. Okay, 4 different tasks will be scheduled. This is task 1 will be getting some access for 5 timer ticks. After this, this task 2 will be getting some access, and task 3 will be getting some access, and similarly task 4 will get some access. Okay, so for each and every 5 timer ticks, it will be getting some access. So that time it will transfer the data to corresponding ports. Okay, is it clear? So for each and every time, but remaining everything same procedure. Okay, like you will be going to project, new mission project. So once you create a project, you can add your C file. That's enough. Okay, see for example, this is my C file. If I want to add, you just remove this one. Then you click add existing file. You just add your file. So this is my schedule file. You just add. That's enough. No need to create project for each and every time. Okay. So just add your file. Then you can go to project, rebuild all target files. Then go to debug, start or stop debug. Okay. Then go to peripheral IO ports, open all ports, because we need 4 ports, right? Port 0, port 1, port 2, port 3. So open all ports, then go to debug, then give run. Okay. If somebody will be in previous experiment, somebody will be getting some that your program might not be run properly. So you just go to device and just click on this NXP. Just click on this NXP. Previously we selected generic 8031. Just click on this NXP 8032. Okay, click on this NXP 8032. If your code is not running properly, just choose the device, different device. Just choose different device. That's enough, right? Just go to NXP 8032. Okay, then you have to check this one. You just keep it in mind. You have to choose NXP 8032, and this first checkbox should be checked. Then your target, your operating system must be RTX51 Tiny. For all, that is from 3rd experiment to 8th experiment, this is the common procedure. Okay, your program only will be changed. If you know the procedure, just you type the code, you can get the output. Okay, right? So any doubt? Any doubt in this? Okay, I'll